So, area. Area. Hopefully this thing works for me. Alright, so area. What? And we will do parallelograms today. Now there are some other concepts that we'll talk about with this that you'll need to apply for all the shapes, but I won't necessarily talk about it for all of them. So, well, what is a parallelogram? Well, something that looks like this. Okay, this opposite sides are parallel. We did a whole chapter on properties of parallelograms and quadrilaterals, that sort of thing. Okay, so the opposite sides are equal. And there we go, there's a parallelogram. Okay, now let's say in this parallelogram that I give you this. What is that I just drew there?
The height.
That is the height. Okay, I am going to need the height. And then one of these is the base. So that's a base and height. But let's say I take the same parallelogram. Okay, and let's say this is my base. Alright, if that's my base, then what's my height?
The long sides.
Yeah, it'd be the other side.
The other side?
Yeah.
What do you mean?
The one that the horizontal, the one that was based on the first one.
Should it be the same side?
Is it this again?
I think so.
No, because it's not perpendicular.
It's the ones that go like that.
Yeah, the horizontal lines, whatever you want to call it.
The other parallel lines.
Wouldn't it be like this? Wouldn't it?
Yeah,
Here.
that's what we were talking
You
about.
said it with the inflection in your voice.
Is that it?
That's perpendicular.
Yeah. Alright, so this is important for the whole chapter. Bases are always perpendicular, that's what that means, to heights. Okay?
Will you explain?
They form a right angle with the base. Okay, so whenever I have a shape, like let's say I have this triangle right here, and let's say this is my base, then that's my height. Now it doesn't matter where I draw my height. Look, I could just as easily draw, you're the one who asked the question to explain, so that's perpendicular, yes. I can draw that height wherever I want. I could draw it over here.
Yeah.
I could draw it over here. I could draw it here. It doesn't matter. Yes, Kevin?
So, like, is the height coming from, like, a corner?
A height is drawn, okay, so a height is drawn from wherever my base is. So I'm supposed to be talking about parallelograms, but the triangle is going to make a good example. So let's say I want to use this as my base, okay? Then my height has to be perpendicular. My height is going to be how tall the shape is. You with me? Does that make sense?
Yeah.
So if I'm using this as my base, then that's my height. Okay, now I can draw that wherever I want, which was the point I was trying to make. I can draw it over here. It's the same. Okay? It's how tall the shape is. Now, you have to use some like orientations in your head here to understand that that shape's the same if I rotate it around. Alright, so we are going to focus on parallelograms today. So let's get a very simple parallelogram. Let's say this is 12, and I give you the height of 9. Okay? And how would I find the area of that? Well, the area of a parallelogram. And I'm going to put little symbols next to this. That looks like a box. I just can't draw a parallelogram really good there. So, it's base times height.
9 times 12.
And as long as we're talking about, okay, so in this case, area of the parallelogram is going to be 9 times 12, which is 108. Now units squared. Okay, whatever those units are, centimeters squared, inches squared. Why? Because we're counting the number of squares inside the shape.
Are you gonna actually count off if we don't like label?
You need to have the label.
Okay.
So yes. Okay,
Oh, boy.
because we're going to get to volume, which is units cubed,
Oh, okay.
and length would be just units. So if I wanted the length around this, that would be perimeter, which we've already done perimeter. Okay, now I told you trigonometry is fair game. So let's say that I give you the same parallelogram. Well, not the same one, but the same basic idea. And let's say this angle here is 70 degrees. Let's say this side here is 10. And let's say this side here is 25. Okay? Now, notice, what am I missing?
A right triangle.
I am missing. See, when I asked this question, Vicky went right to height. Why do we go right to? I mean, you could say, well, I'm missing the other angles, Mr. King. Well, yeah, but I'm specifically asking, what am I missing that I need to know? So, in order to find the area of this, I need the base and the height. So, Victoria's correct. I need the height. So, draw it. Okay, you are going to have to often in this chapter draw in pieces of the shapes that are not there. So I don't have the height drawn in, and I can draw it wherever I want. I'm going to draw it somewhere that is helpful. Okay, right there is helpful. Well, why is that helpful? Because what do I have right here?
A right triangle.
I have a right triangle. So I'm going to take that right triangle, and off to the side, I'm going to figure out something about it. I'm going to figure out my height. You could label it as X if you would like. No, you should be taking notes. Okay, we're going to figure out that height. How could I find that height?
Would you use sine?
Yes.
Sine of 70 equals
H over 10.
H over 10.
Sorry, Evan.
So 10 sine 70 equals H. Okay, so let's get that to the nearest tenth just for our purposes. What is that to the nearest tenth?
9.4.
Okay, 9.4. Good enough for right now. So this is 9.4. Now I'm able to go ahead and find my area. What's my base?
25.
And my height is 9.4. Now why isn't my base 10?
Because you would have to draw it
The
perpendicular
line's
to
not
the 10.
perpendicular to the 10.
Yeah, it's not perpendicular. Okay? I could have used 10. I could have, but the way I drew it, I did not. So what's 25 times 9.4?
235.
Yep, 235.
In units squared, whatever our units happen to be.
So we times that by 25.
9.4, yeah, because the height, base
Okay.
times height.
And that's our final answer.
Yeah.
Okay. The next example, I don't want you to copy down. I want you to follow along with how I'm doing it, because it is in the video. Okay, because it'll take you a while to draw this, and I don't want us to waste time on you drawing that. So, I have no information on this. It's just been drawn. You all looking?
Yes.
Yes.
And I want to find the area of this parallelogram. Well, in order to find that area, I need the base and the height. Suggestions.
Count the blocks.
Count! Yes! Or, if I can't count it, if it's all diagonal, then I can use my distance formula from earlier in the year, which is, by the way, fair game. Alright, but in this case I can just count. How long is this base?
5, 6, 8, 9.
Yeah.
Do you
Okay.
count the partial boxes?
You would if there were any.
Well, isn't there some in there?
No.
Not for just the base that we're gonna use.
Okay,
You
so
see?
1, 2, 3,
Okay, I
4,
see.
5, 6, 7, 8, 9. Alright,
Okay.
what else do I need?
The height.
Which is 5.
Okay, and I might draw it in here. Alright, there's my height, and that's 5.
Right triangle.
Well, we
But I don't
it.
even need that. I just want the area of this.
Great. You thought that you were
Okay,
right.
good seeing right triangles, but I don't need it in this case. So 9 times 5, which is
25.
45. Okay? Next one. Alright, now this is a triangle. So actually, let's back up. Let's do a triangle. So write this down. Area of a triangle.
We're starting with something. You know.
Yes, I can do the little section.
Well, it's not its own thing. Okay, so don't make it harder than it needs to be. All right, I want you don't need to write down this reasoning, but I want you to understand where we get this. Every single area formula comes from a parallelogram. All of them, including circles. So, what's the area of this?
Base times height.
The area of that is base times height. Now, if I wanted to make a triangle, some of you have heard this lecture before, so you know where I'm going with this. Do you agree that I've cut that in half and have formed a triangle right here?
Yes.
So this is half of the whole thing, right?
Yes.
All right, so this is what you need to know. The area of a triangle is the base times the height and divided by 2, because it's half of a parallelogram. Okay, so you can express every shape, actually, you can show every shape is actually a parallelogram sliced up somehow, some way. Alright, so area of a triangle. Let's do a right triangle first. Here's a right triangle. What's the area of that right triangle?
36.
It is 30. I write my formula down, and yes, I insist, you write your formula down. What's my base? Gentlemen.
6.
What's my height?
10.
And then we're going to divide by 2. You can do that in any order that you like. It might be convenient to do 10 divided by 2 first. That gives me 5. But in the end, no matter which way I do it, 30 units squared.
If we don't write a formula,
Points off. Write your formulas.
oh my.
I know that you know, or I hope that you know, area of a parallelogram and area of a triangle already. But by the end of the chapter, you're going to have some area formulas that you have never had before.
So if they're like really simple ones, do we have to write them still?
Yes.
Oh my goodness.
Because I know what's going to happen. Oh, Mr. Kane, it takes me 5 seconds to do this.
It takes up a whole line.
It takes space.
That's the
Stop
thing.
complaining.
Valuable space.
Okay. Maybe I have a triangle that is not right. Even though this might
That
look
looks
right.
very
I did
right.
not mean it to be right, so whatever. Okay? Okay. How do I find the area of that triangle?
Which one's perpendicular to it?
12.
Which one looks like to be perpendicular?
12.
8. Not the 9, right? It's all slanty.
Yeah.
Okay? So, formula. Area of a triangle is?
B times H over 2.
I expect to see that first. Okay? 12 times,
8
why not the 9?
divided by 2.
Because the line's not perpendicular.
That's just the side.
Yeah. Sides are not necessarily heights. They can be, but not necessarily. Okay, we're going to do one more triangle before we get to that diagram, and I want you to definitely write down this triangle that we're about to do. Okay, what type of triangle is that? It is a right triangle. I want to find the area of that right triangle. So I write down my formula, do that first so you know what I'm looking for. I need a base and a height. Okay? What am I missing?
The height.
The height. I need the height. How am I going to get the height?
Height bag.
Yes. So do you see how the different sections that we've already done play into what we're doing now?
Yeah.
Okay, so you are expected to find that height. You identified what we're missing. We're going to find that height. We're going to use Pythag. So 7 squared plus height squared equals 12 squared. So we have 49 plus the height squared equals 144. We'll subtract the 49,
95.
and then we'll take the square root.
You want actual or?
Well, we'll leave it the way it is. So we'll leave it as root 95. So, but you could round to the nearest tenth. I just want to show you doing exact. So the base is what?
Base is 7.
Okay, and what's my height?
Root 95.
Root 95, and then divided by
2.
2. Since I did that exact, units squared, and I'm done. Okay? If I'm going to estimate, I put that in my calculator.
34.
Okay, so Justin, I replaced base with 7. You with me?
Yes.
I replaced height with root 95 because I figured that out, right?
I got confused on the Pythag. You were going so fast that I think I
Okay,
mixed up
so
my
this is my hypotenuse.
Yes.
This is one of my legs.
Yes.
This is my other leg.
Yeah, I mixed up my
And then
numbers.
we've done Pythag, that's why I went fast on that. We've done that several times.
Oh, you even had it written up there. Okay, yeah, I mixed up my numbers.
Okay, so let's go to this triangle. I want to find the area of that triangle, so I write down my formula.
Do you want us to draw this triangle or
Nope.
watch?
Nope. Don't draw it, it'll take you too long.
Right.
Okay? How am I going to do it?
Count. Do the top one.
The flat one, yeah, that'll be our base. That's simple.
And that's how much?
7, I believe.
6.
Okay?
And then we should
Well,
go.
if I choose this to be my base, that forces me to have a certain height.
Well, it's not. You have to find. Yeah.
That's fine.
That's my height.
Well, it's not exactly 5.
Oh.
What do you mean it's not? 1,
Oh, yeah, it is.
3,
Yeah.
4, 5, 6,
7.
7. 7, because we can count.
Oh.
Okay?
Yeah.
So, it doesn't matter where I draw that. I could draw it there. I could draw it there. No matter where I draw it, it's 7. Okay? So we
6
get
times
6
7.
times 7 divided by 2. In this case, I might divide that 6 by 2 first. Then I will get 21 units squared. Any questions how we did that with the drawing?
No.
Okay, so now we do need to go back to the parallelograms and we're going to find missing parts. So this, it's going to be hard for you to draw, but try your very, very best.
Try our very, very best.
It is a parallelogram. All right, so this is where things are going to get a little bit tricky. Okay, where we're going to have multiple steps. We'll do another pair of these in a moment. And then we will go on to the last thing for today. Okay. I want to find y, because I do not know it. But I am told what x is. X is 10. Okay? If I move that 10 in, I see it would be perpendicular to what side?
The 9.
The 9. Okay? So, here's what I'm going to do. I'm going to find the area of this shape, base times height, and I'm going to use the information I had. I can use this 9 and this 10 to find the area of that shape, just like I could use the 12 and the y. Are you with me?
Mm-hmm.
Right? So, the area of this shape is going to be 10 times 9, which gives me 90 units squared. So the area of this whole thing's 90 units squared. You with me?
Mm-hmm.
I want to find y. I want to find this length. Okay? So I could also find the area of this shape by doing base times height again, but in this time using the 12, and the height is y. Since I've already calculated the area as 90,
Oh.
I know the area this time, and I can find the height, or the y. And I divide, and I get 7.5 units. So we'll do another one that's similar.
I can't draw that like at all.
That?
Yes.
Here, I'll show you, Joe.
Thank you. Please draw it.
Which are you trying to draw down?
Let's do one that is simpler, and then we'll go back to one that is complicated.
What you do, you just draw 2 straight lines. Different angles. And connect them.
That's supposed to be a parallelogram.
Except for his is a little more fatter. And you got the gist of it.
All right, so in this parallelogram that's horribly drawn, I'm told that the area is 56, and I want to find x. With me, Kip? Pay attention. Okay, idea.
Okay, so you do 56.
Well, hold on, I write my formula. Okay, now what?
Right, 56 equals B.
I'll replace it with x, but yes, you're right.
7. Then you divide by 7 and 8.
So 8 units, whatever those units are. Yes, that's correct. Okay, that's basically what we were doing with the other example,
Except it looked more complicated.
and it definitely was more complicated. All right, so we'll do another one that's complicated. Get that one down, however. It's in the way it's drawn that makes it really look tricky.
How much more complicated is the next one going to be?
You're about to find out, right?
Semi-complicated.
So here's my parallelogram. Let's say this is 8. Say this is 10. Say this is 14 down here. And let's say I draw this height right here. So I mean that to be a height. We'll call that x. Now I'm meaning that to be perpendicular to down here. Okay? So I can draw my heights wherever I want. Alright, so I need to find x. So I'm going to find the area of this parallelogram because it doesn't matter which heights and bases I use, I should always get the same area. So the area of this parallelogram, just use the information that's clear, 8 and 14. You with me on the 8 and 14?
Yes.
Alright, so 8 times 14 gives me which area?
112.
Alright, so that's my area of this shape. Now the area of the shape is not going to change, but now in order to find this x, if I use this x,
You have to use the 10.
I have to use the 10 because it's perpendicular to that 10. So,
112.
yep, I will do the 112. So it's 112, and then my base now is 10, and my height now is x. Divide by 10, and I get 11.2. That's my answer. I figured out x. Okay?
Clean.
Any questions? Then we can do the last thing for today. Now this is fair game throughout the chapter, but the concept is not going to change. Okay? So, let's say I have a square, and for some reason I'm really having a hard time drawing that square. So, I have a square. Then inside of my square, I'll have a rectangle. And then I am going to shade this part right here. So that's the area I want. Okay, beautiful shading, Mr. King. Alright, so let's say this side, so this is a square, so these are all the same. Let's say those are all 9. And we'll mark these. Alright, we'll say this side in here is 8. And this is 3 maybe. Find the area of the shaded part. So besides the honors students, who has an idea how we could get the area of just the part that's shaded, not including this part that's been cut out?
Well, you would find the area of the square and then the rectangle, and then subtract the area of the rectangle from the square.
Okay, he's right. So I'm going to take the area of the square, and I'm going to subtract the area of the rectangle. And why do I do that? It's like a donut hole, right? So I'm going to find the area of the square first. It's still base times height. It's the same formula. Okay, because rectangles and squares, those are all parallelograms. It just happens that the height and base are the same. So the area of the square is 81 units squared. Alright, and then I'm going to do the same thing for the rectangle. 8 times 3. And I get 24. So the area of the square is 81, and I'm going to subtract from it the 24 and get my total area. And the way I'd write that is area final.
Just your little square share.
So it is what?
57.
57 units squared. Any questions how we got that?
Nope.
Two more then.
Aren't we gonna be? Never mind. I was thinking about what I was saying. Continue. I was thinking about one of those squares that's deformed where you have to figure out this missing sides and everything. Is this part of the shaded area?
Yep.
Okay.
Sometimes there's several ways to do it, and in this case it may appear to be several ways, but I actually only see one way to do this one. Notice this is hash marks, so we know this side is also 10. Now, you might think, oh, to find this shaded part, I find the area of this triangle, and I could add to it this triangle. But I do not know this length or this length. I don't know where that point is. So I'm not going to be able to do it that way.
Make it into a square.
So instead, what I would do is complete this rectangle right here. And I would say, all right, I could find the area of this rectangular piece that actually looks more like a square than it does a rectangle. And I would get that area as 300. So I get the area of the box is base times height, which is 30 times 10, which is 300 units squared. And then I'm going to subtract from it
You do area of the triangle.
that big triangle there in the center, right? This one. I'll take that area away. Well, do I have enough information for that? Well, yeah. This side is
30.
and this height is
10.
10, is still 10. So the area of that triangle there that I'm going to take out is base times height divided by 2, which is 30 times 10. Okay, divided by 2, which is 150 units squared. So my area final is 300 minus the 150. Get 150 units squared. Sometimes you do add the pieces together, but I think that's sufficient that you get the idea. Who's good? Thumbs up if you're good.
I'm good.
All right. Good. Put away your...